It is safer to write E, okay, for identity element, okay, because there are different types of identity. Since additive identities is what? 0, isn't it? Multiplicative identity is what? 1. Okay? So for example, in a multiplicative group, where this is multiplication, if you have G star, G inverse is going to be G times 1 over G, which is equal to 1. 1 now is the multiplicative identity, isn't it? For additive group, G with star, where this is additive, G star, the inverse will be G minus G, which is 0. 0 is now additive identity. So unless otherwise explicitly stated that your group is additive or multiplicative, you cannot figure out what your E is. Okay? It depends on the nature of your group. Which is additive, the identity is 0. Which is multiplicative, the identity is 1. If it is something else, like symmetric sum or symmetric difference, the identity will be entirely, will not be 0, will not be 1, will be something else. Okay? Good, that is 1. Remark 2. Remark 3. These axioms are unique. Axioms of identity and the inverses are unique. Okay? Especially. For example, identity, uniqueness of identity, if you have two identities, E and E dash. Okay? If E and E dash are two identities, of the same group G, then it can be shown that E will be the same as E dash. They are the same. Is it clear? You can prove it, proof. Regarding E as the identity, okay, you are going to have what? E star G. Let me even use the group code. Element of the group G code is equal to what? G. This is a question mark. And if you regard E dash now as the identity, what happens? E dash star G will also be the same as G. Question 2. You will notice that the right hand side of 1 and 2 are what? Are the same, isn't it? They are all equal to G, isn't it? Therefore, what happens? Left hand side must be what? Must be same. What does that mean? It means E star G is the same as what? E dash star G. And if you use cancellation law, what happens? Using the cancellation law, can clean this to apply the cancellation.